Welcome back with the lesson 2 for upper and lower limits of a sequence of real numbers. Last time we have done a theorem. Now we will be doing one example which is very important. Example: for any two subsequents an and bn, we have to prove that limit n tends to infinity supremum of an plus bn less than equal to limit n tends to infinity supremum of an plus limit n tends to infinity supremum of bn, provided the sum on the right hand side is not of the form infinity minus infinity. Right? So we have to prove this inequality. Suppose that if this RHS part is equal to infinity, let's say that if the right hand side is infinity, then there is nothing to prove. Obviously, left hand side is less than equal to the right hand side because it is infinity. So if RHS is infinity, then there is nothing to prove. The inequality holds. Then there is nothing to prove. Now let's say that if RHS is minus infinity, then if it is minus infinity, then one of an or bn converging to minus infinity, and suppose this first part is converging to minus infinity and the second will converge to any real number, or second is converging to minus infinity or the first will be converging to any finite limit, or both may converging to minus infinity. Right? This case can happen. What can happen? If RHS is minus infinity, then one of either an or bn converges to minus infinity and other converges to a finite limit. Fine? Or what can happen? Or both may converge to minus infinity. Right? So therefore, can we say that an plus bn, this will converges to minus infinity? Yes. Okay. Now, which means if we take the limit n tends to infinity supremum of an plus bn, this limit equal to, because if an plus bn is converging to minus infinity, that means if we take the supremum and take the limit, then this will is equal to minus infinity. Right? So which is equal to, this is nothing but what? Limit n tends to infinity supremum of an plus limit n tends to infinity supremum of bn. Right? Okay. Now let's say that if our RHS is a real number which is not plus infinity or minus infinity, suppose it is converging to, it is just a real number, then how can we prove that? Then let limit n tends to infinity supremum of an plus limit n tends to infinity supremum of bn. This is our RHS part. Let's take the first one to be equal to alpha 1 and let's take the second one to be equal to alpha 2, where I have named limit n tends to infinity supremum of an to be equal to alpha 1 and limit n tends to infinity supremum of bn is taken to be as alpha 2. Now therefore, for given epsilon positive, there exist positive integers. I'm mentioning the two integers n1 for alpha 1 and n2 for the other part, such that for the first one, if the limit n tends to infinity, supremum of an equal to alpha 1, this means an minus alpha 1 is strictly less than some epsilon by 2 for n greater than equal to n1. Just definition is used for this part. And also for the other one, bn minus alpha 2 is strictly less than epsilon by 2 for n greater than equal to n2. Fine. Which implies, take this alpha 1 to the other side. An is less than alpha 1 plus epsilon by 2 for n greater than equal to n1, and bn less than alpha 2 plus epsilon by 2 for n greater than equal to n2. Fine. Now let's take our n, capital N, to be the maximum of n1 and n2. Let's take. Put n to be equal to maximum of n1, n2. Because such thing happens for n greater than equal to n1. And the second thing is also happening for n greater than equal to n2. For both greater than equal to n1 and n2. That's why I have taken the maximum of n1 and n2 togetherly. Okay. So then an is less than alpha 1 plus epsilon by 2 for n greater than equal to n. And bn is less than alpha 2 plus epsilon by 2 for n greater than equal to n. Sum up. We are adding these two, an plus bn less than alpha 1 plus alpha 2 plus epsilon for n greater than equal to n. But epsilon was arbitrary, right? But epsilon was arbitrary. So therefore, let's take the limit now. Limit n tends to infinity on supremum of this an plus bn. This will less than equal to alpha 1 plus alpha 2. What is alpha 1? We have taken alpha 1 to be as limit n tends to infinity supremum of an. What is epsilon 2 taken as? Limit n tends to infinity. Just put back the values for alpha 1 and alpha 2. Supremum of bn. Now why I have taken the sign equality with less than? Because it is strictly less than now. Why I have taken this equality? Because here equal to comes because we are taking the limits now. Whenever we take the limits on the inequality, we make the sign strictly less than as less than equal to. Remember this point. Whenever you take the limit on any inequality, this sign changes to the less than equal to. If it is greater, then this will changes to greater than equal to. Here it is less than, so it will changing to less than equal to. Right? This is what we need to prove. Alright. Thank you so much for watching this video. Next time I will be coming up with the topic rearrangement of series of real number and complex number, and then the Riemann theorem. Thank you for watching this video. Thank you for your support. God bless you all. Have a very lovely and good day.